Hi everyone, my name's Noah. I'm a product manager at Algorand, and today I'm going to apparently talk to you about how we can secure cross-chain bridges with Algorand state proofs. So bridges are great. Over the past couple of years, we've seen a rise in the number of layer 1 blockchains, creating a fragmented ecosystem where users, developers, and liquidity are often siloed away from each other. With each blockchain offering different currencies, business opportunities, and communities, there's been no good way to jump between these different crypto nations. So, similar to how a bridge connects different pieces of land, a blockchain bridge connects different blockchains. But rather than transporting cars and people, a blockchain bridge moves assets and information, providing convenient ways to explore new ecosystems and projects. But like many new technologies, they're risky. With over $12 billion locked in Ethereum bridges alone to date in this bear market, there is a large target on the smart contracts and validators that secure these bridges, with a number of high-profile hacks happening in recent memory. Now, while nothing is bulletproof, we should look for ways to reduce this attack surface and secure cross-chain liquidity. So let's start with a basic example. Say Alice is on Algorand, and she wants to move 10 algos to Bob, who's on Ethereum. Your classic bridge works through a series of smart contracts that you can kind of think of as lockboxes. On one side, you either lock or burn some algos, and on the other side, you mint the equivalent version. But since we're not in the money printing business, in order to unlock these algos on the other chain, the minting smart contract needs a way to verify the deposit on Algorand. Now, since blockchains can't natively communicate with each other, the Ethereum app needs to find a way to ask questions about Algorand state. So what are its options? Well, the bridge could turn to someone like a centralized intermediary, who you can think of like a bank that's living in multiple worlds. Maybe they run both an Ethereum node and an Algorand node, and there's no real way to know if they're honest. So a bridge would be exposing its users to new points of trust. And even if you can trust this bridge, as a single point of failure, we know that honest middlemen can be hacked. So let's say we cut out this single intermediary and instead introduce a network, some kind of committee that together reaches consensus on the state of the Algorand blockchain. The idea here is to spread out the attack surface, to have more checks and balances to encourage honest play. And while it's harder for any one single validator in this network to be hacked or to cheat, you're still exposing your users to new points of failure and are effectively trusting a third-party network to replace the job of the blockchain itself. What if we could cut out these middlemen entirely and simply ask the Algorand network questions itself? This is where state proofs come in. State proofs are new infrastructure that let entities outside the Algorand blockchain to securely track and verify Algorand state. Now, when I refer to state, I'm talking about transactions, account balances, the state of different smart contracts, really any information that the Algorand network can reach cryptographic consensus on, we can export into a state proof. Conceptually, you can think of each state proof as a short letter that summarizes recent blockchain activity and happens to be signed by a large chunk of the Algorand network itself. So it's kind of like writing a short letter that says, here's all the recent stuff that I saw on Algorand, and by the way, it's signed by, say, 80% of the entire Algorand network. That provides a lot of confidence. Looking under the hood, each state proof is a compressed set of signatures sent by Algorand consensus participants attesting to some statement or event. In this case, what you can think of is a lite block header. Now, consensus participants on Algorand nodes every 256 rounds will assemble this summary data, sign it, send it to the network, and then those signatures will be compressed into a compact state proof. Okay, so we have these fancy state proofs, but what can I actually do with them? Well, coming back to the original problem, we're looking for ways for dApps on other chains to ask the Algorand network questions. As portable proofs, you can send each state proof to a different blockchain to cryptographically verify state without trust in an intermediary. So how do these other blockchains keep track of Algorand state? Well, if this blockchain has smart contracts, like Ethereum does, you can build applications that we like to call lite clients. A lite client is kind of like an oracle that can answer questions about its area of expertise. In this case, the lite client will ingest and verify each state proof and learn about Algorand blockchain state. From there, it can answer yes or no questions like, did Alice lock 10 algos in XYZ's bridging smart contract on round 1, 2, 3, 4, 5, 6, 7? So let's review the process. Alice is on Algorand, and she wants to send 10 algos to Bob, who's on Ethereum. First, Alice will deposit 10 algos in the Algorand locking or burning smart contract, and that transaction will get recorded into a state proof. The state proof will then be signed by, say, 80% of the network, which can then be sent to the lite client, who verifies and stores the summary data. Now, this is where it gets interesting. Normally, the bridging minting smart contract would have to ask some intermediary about this transaction, but we can completely cut them out and simply ask the lite client, did this transaction happen, yes or no? If yes, the bridge can mint the Ethereum, the wrapped algos on Ethereum, and we complete the export picture. Now, while validating individual transactions is interesting, we wanted to make state proofs more broadly applicable. So each state proof attests to all recent activity over some period of time. What this means is any Ethereum dApp can use the lite client to trustlessly verify Algorand state. To start, it's going to verify transactions, but we can expand the state proof message to include things like I mentioned earlier, such as account balances, the state of smart contracts, really any information that external parties would find useful. So you can imagine a lot of interesting use cases for this technology. We talked a bit about trustless bridges, but you can imagine trustless cross-chain exchanges, oracles, or really whatever else the community can think of. Let's go with an exchange example. Say I'm on Algorand and I'm kind of siloed in this ecosystem, but there's some new awesome dApp that came out on Ethereum. I have an ecosystem startup problem where I need to first create a wallet and then find a way to fund it. Typically, I'd go through some kind of centralized intermediary, kind of like maybe a centralized an exchange, or maybe going through a trusted bridge, which we've laid out the security concerns with earlier. With state proofs, you can effectively perform a cross-chain atomic swap where you deposit algos on the Algorand side and withdraw native Ethereum on the Ethereum side, all without trusting an intermediary. So let's go to an oracle example. So let's say there's some fancy oracle that can attest to some real-world activity or something that they saw on the blockchain. We can export this oracle state to third parties that either don't want to or can't keep track of blockchain activity. So if there's an oracle that can verify the outcome of a sports game or confirm that Austin, Texas really was 105 degrees for the entire consensus conference, we can export this to external parties without trusting an intermediary. So how does the lite client work, and why is it considered trustless? Well, to answer this question, we have to go to a little bit of a backstory. One of the major blockers to launching trustless lite clients has been the cost of validating block headers inside of a smart contract. In a perfect world, we would just run Algorand nodes and smart contracts on all blockchains, and everything would be interoperable. But we live in a world with limitations. Due to gas costs, transaction size limits, and other things, this makes it simply infeasible. So we created these pretty small state proofs. But to minimize costs in fee-constrained environments, we are also working to produce something called a zero-knowledge snark proof. Now, bear with me, this is going to get a little bit meta, but each snark proof is basically a proof that a state proof exists. It'll witness the state proof and then produce an ultra-compressed version of it that can be used to efficiently update these lite clients on other blockchains. So we take a proof, whether it be a state proof or a snark proof, we relay it over to the lite client, who then says yes or no, either like you're telling me the truth or no, you lie. Now, each lite client is very particular. It has a high bar of excellence. The only way to advance the state of a lite client is to get enough signatures from the Algorand network itself. Now, because you already trust the Algorand network's ability to agree on transactions and new blocks, or else you wouldn't be using the blockchain in the first place, we call this lite client trustless. So how does the lite client actually answer questions from other dApps? Well, attesting to blockchain activity is the really hard part for a bridge, and honestly not part of its core competency. So we wanted to make it as easy and secure as possible to get this information. So the dApp in question will simply retrieve some transaction data from the Algorand network through its SDKs, relay it to this bridging minting smart contract, who will then send it to the lite client to say, did this transaction happen, yes or no? The lite client first checks that the transaction is in fact part of the claimed block, and that this block is part of the summary data that the lite client has already verified. If both check out, then we have a success. We can mint the tokens on Ethereum. So I'm going to change gears a little bit. So far, I've only talked about ways to leverage state proofs on other blockchains. Our cross-chain picture would not be complete without also importing things to Algorand as well. Say we wanted to import some ERC20 token into Algorand. Similar to the export scenario, anyone can build a trustless Ethereum lite client on Algorand that tracks and verifies Ethereum state. Now, this is fairly straightforward for proof of work. You simply need to check the proof that the work happened, which means checking some block headers, some hashes, and the nonce. But for proof of stake, it's a little bit harder. In order to prove the state, you need the stake. So there's Algorand state and then the stake from the network. You have to first compute all transactions from Genesis to get the current account balances. And once you know the current state of the world, you can use that to check the signatures coming from network participants. Am I getting the correct signatures? How much weight should these carry? These are crucial pieces in order to verify a proof of stake blockchain state. Now, Ethereum is building lite client support for after the switch to proof of stake, but Algorand can support both the proof of work and proof of stake versions. However, the world is not limited to just Algorand and Ethereum. All proof of stake chains face this challenge and will have a difficult time supporting truly trustless bridges without introducing their own version of state proofs. So let's recap this a little bit. Bridge operators have been tasked with the really hard job of securely validating multiple blockchain networks. As layer 1 blockchains, we have an opportunity to reduce the distance between us and get us closer to our decentralized roots. Algorand state proofs provide a simple, trustless interface for anyone to leverage the Algorand blockchain, removing this difficult network validation challenge. State proofs could become part of a new interoperability standard that securely brings blockchains closer together without trusted intermediaries. This will give developers more options to choose the underlying technology that's truly right for their application, providing their users with the best possible experience without limiting them to the walls of their own blockchain ecosystem. Now, there are plans for a pair of lite clients to be deployed on Algorand and Ethereum, but a network of blockchains that incorporate their own version of state proofs would create a more simple and secure ecosystem for all. So where do we go from here? First, state proofs will be available on the Algorand mainnet next month. Once these are available, anyone can build Algorand lite clients on other blockchains. But to make things a little bit better, we're also working on snark proofs, which are on deck. These will make it even cheaper to run Algorand lite clients, which is important for builders that are working in fee-constrained environments. Thanks for listening. Next up, we're going to hear from some of the builders in the ecosystem on how they plan to utilize Algorand state proofs.
Great job, man.
Thanks.
Yeah. All right. Well, so here we are. That was fantastic, Noah. Thank you so much. You know, I was just on Twitter. I saw that Algorand's block 0 was exactly 3 years ago. And just for everybody's information, it's never been down. And I think most people sort of agree that if you know about Algorand, you know the great tech. You just heard about this. This state proofs is pushing that forward. You know, Silvio Macaulay, he's the co-creator of zero knowledge proofs and verifiable random functions. And now state proofs. And then even if you were to remove Silvio, you have Chris Pikert, who is basically, if you Google him, he's a ZK Snarks guy. So Algorand's got great tech, and we've got some incredible builders here. You just heard from Noah, and we also have Michel Dahdah. He is the co-creator or the co-founder, CEO of Rand Labs, responsible for My Algo Wallet, Algo Explorer, and then more relevant to this, C3 Protocol. And then we have Ben-Ari. He is the co-founder and CEO of Applied Blockchain and the London Bridge, which is a bridge waiting for state proofs, right, to go to Ethereum. So I guess, you know, he covered it, he talked about it, but you know, we all talk about a multi-chain world, you know, but we're all in these islands and we're not really talking to each other. And we have to rely on mainly these centralized bridges that if you open CoinDesk, you're always getting all of these different hacks and all this stuff. So state proofs is supposed to create something trustless. So why don't we start with you, Michel, and talk about C3 protocol, how state proofs is going to make that something that is secure, decentralized, and you know, something you can trust.
Yeah, so C3 protocol is essentially a cross-chain DEX where all of the clearing and settlement is happening on Algorand, but users will be able to use assets from any blockchain and, more importantly, any wallet. You won't have to be switching wallets or anything like that, given the design of C3. So the way we're using is state proofs, or basically transmission of states from one blockchain to the other, is for user deposits. Once you want to trade on C3, you'll have to use any wallet from any blockchain supported, log collateral in your blockchain of choice, and execute trades. And whenever you want to withdraw, the smart contract in the original blockchain needs to know what the state of those balances are to know how much you can withdraw from the request. And that's where we're actually leveraging something like state proofs that allows us to, in a trustless way, export a state of all of our settled trades back to the original blockchain so that users can withdraw back their collateral after finishing trading.
Yeah? And then how about you, Adi?
Yeah, so we're building a bridge called London Bridge, and we're using this state-proof technology. As a company, we build blockchain applications for clients. We build a whole range of applications on Algorand, you know, one of the reasons why we use and like Algorand is that because the technology is very solid from the ground up, and it really has a fantastic set of engineers behind it, sticking to their principles and making sure that everything is very secure. And I think that these state proofs are just an extension of that, and they allow the Algorand applications to be extended beyond Algorand itself. So it's not just about bridging, it's also about being able to rely on data and things that happen on the Algorand blockchain and being able to verify those in other blockchains. I was going to say that it really amazes me how in this space, you know, we've been in this space since 2015, how people get very religious about the blockchains and how secure they are and the mechanics in them, but you very rarely hear this about the other components like bridges. So you've got your assets on the blockchain and everybody's really concerned about that. But when you're moving your asset across, you're really exposing it completely to the security of the bridge. And the security of some of the bridges we've had in the early days are quite horrific. Yeah. Right? You just have a single entity, as Noah described, and they have a key to mint tokens on the other side, and they can really do as they wish. Right? There's no cryptography and nothing really holding them to account. And if someone compromises their servers, then it's the same thing. So it's just amazed me how so much value has gone across bridges that no one's really bothered to look at very closely or to call out the security risks. And it's great that what we're seeing here is some fundamental underlying security work to actually make sure that things are done properly in the first place.
Yeah. You know, we all know about centralized bridges, but like there are things that people say it's a decentralized bridge. Now, what is, you know, Algorand is building, or what C3 protocol is building now, how does that set apart from something that is called a decentralized bridge and, you know, something that like this, which would be more truly decentralized?
I think the main point here is that when you're communicating across chains, you want to avoid losing like the security guarantees of the blockchain in which you're operating, right? Because if you have all this honeypot in a single place, then that becomes the main attack vector for someone, for hackers, right? So if that's not as secure as the blockchain itself, then it becomes, you're breaking a lot of the security assumptions in a future world where we all know it's going to be cross-chain, right? And that's where something like state proofs comes in, where the way you're securing the bridge, it's not only about decentralization at the end of the day, it's more so like you're using the same security guarantees of the network itself where you're operating in, to basically bridge assets, right? It's you need 80% of the stake of the network, which is essentially almost the same guarantees of the network where you're operating, to be able to provide these proofs or generate these proofs so that bridge can correctly function.
Another way to think about it is the reason why you trust a blockchain in the first place is cryptography. But in a regular bridge, that cryptography kind of stops with the bridge operator and then starts again on the other bridge. You just don't have the link. And this is a way of making that link directly with cryptography between the blockchains.
Yeah. Right. And I think that like sometimes a lot of bridges claim to be trustless or decentralized, but if you put like some scrutiny on those statements, there's usually some kind of intermediary to actually relay the state across blockchains. And with state proofs, the intermediary doesn't exist. You're literally like the only thing you have to trust is the Algorand network and whatever other blockchain you're going to. Sometimes these trustless bridges have some economic incentives or some kind of validator network or even some kind of slashing mechanisms. And you have to trust that those economic incentives will keep the bridge secure. But at the end of the day, those are additional points of failure. And I think that people that use bridges should be aware of the additional risk that they're taking on, which is not always fully disclosed to them.
Yeah, and for us as builders, we're always trying to like come up with a solution that has the lowest like attack surface, right? So like the simpler it is to implement, the safer you can be. It's going to be easier to audit because there's less things that could go wrong, and like having solutions like SafeProofs kind of brings you that same like this minimizes the attack surface. So when you're developing, you kind of have the same security assumptions that you would when you're building on an L2 on Ethereum, for example, right? Where what could go wrong is how you're locking assets in the smart contract that is then represented in the L2 computations. Similarly, on SafeProofs, you know, what could go wrong is the smart contract that's locking the asset, right? Which is kind of it's the exact same risk you're taking with like any other scalability solution you're looking at.
Yeah. You know, I talk to a lot of people, I talk to developers, they're like, you know, the AVM is great, but it's, you know, it's something new for them to have to learn. And I feel like it's kind of, sometimes it's a barrier, maybe it's easier to be EVM. And I know Algorand wants to be EVM compatible. You had mentioned, yeah, it's great to export from Algorand, but it would also be kind of nice to, you know, have those assets and have these apps be able to be, you know, cross-chain and bring stuff and TVL in. What is the, you know, look, I'm not a technical person here. So what is the process? Like, is it going to be on, you know, builders like you to build these lite clients on these other chains? I mean, that's just basically it, right? So that's how this is going to get done? Or
yeah, I think there's,
go
go ahead.
No, go on.
I think there's an important component here, which is that like Algorand did a great job for them to be able to easily export the state of the network to other places, but it's also on to other blockchains to work on similar solutions so that they're using the same network to provide the proofs of the state of your own blockchain, so that cross-chain interoperability can happen in a very secure way without requiring any of the intermediaries that today exist. So it's hopefully, you know, this type of like there needs to be more education about the needs of this, and hopefully more blockchains core teams will put that work into doing what Algorand just did.
Right, and at the end of the day, you're going to have these blockchains that have some state proofs equivalent solution, which gives the builders and their ecosystem the assurances that you have this secure, simple bridging, or not. Again, it's not just bridging, but you have a way to reduce the distance to other blockchains. So there's going to be a network of layer 1 blockchains that have these security principles that extend outwards, and then you have the ones that don't. And we're trying to bring about a more secure, simple ecosystem for everyone. So we would love to see other blockchains adopt this as well.
And back to your question, I mean, for Ethereum, if you want to validate Ethereum, there's some pretty standard code out there for a lite client, right, in almost every language. So it becomes a standard thing. And because state proofs themselves are something from the network itself, from the protocol, then again, you'll have 1 or 2 implementations, and then people will just follow those and use them wherever they need.
Right.
Yeah.
You were talking before we came on about maybe there's some similar, is there similar technology to state proofs on these other ecosystems, or is this unique, or if it is similar, how do they differ?
Yeah, well, I don't know the exact details on the technical implementations of other ecosystems, but we're starting to see other ecosystems looking for solutions like this, right? I know there's a team called like Composable Finance. They're building on this type of implementations on Polkadot. There's another one on IBC, so Cosmos, where the entire paradigm is how can you leverage that network itself, like if it's the network of validators running the blockchain or the stake running the blockchain, to leverage that to generate the proofs needed. So we're already starting to see that in a couple of other ecosystems, which means the narrative is starting and kicking off. And I think this is very bright for those, like you see Vitalik, he criticizes the cross-chain future because he believes all the solutions will always depend on like a certain group of validators that can be attacked, or like you can do like DDoS attacks to the nodes running the bridge and do double spend attacks. But now we're seeing with solutions like this, and not only Algorand but other blockchains adopting it, that there's going to be ways in which you do not lose the security guarantees of your blockchain to have this cross-chain communication take place. So it's like it's inevitable, and it's just a matter of time, in my opinion.
I was going to say, one of the beautiful things about blockchain is that you can actually see everything, right? You can see how it's constructed, you can see the code, you can see the contracts, you can see the risks, right?
Yeah.
The tragedy is that a lot of people don't bother looking, right? So even if you think about Terra and you know what happened in the last months, it didn't do anything it wasn't supposed to, right? We wrote a report in January where we looked closely at the protocol and how it would work, and this was one of the risks that we documented, because if you look closely enough and you see how it works, and it says it on the tin, then it's one of the things that could happen. And people don't, it's the same thing with bridges, people don't necessarily look closely enough. So we're telling you this is extra secure, but do you really know that the other bridges are not? You know, people need to look closely at this stuff, because the beauty of it is transparent, you don't have to rely on anybody, but that means you have to do your homework.
All right, so you're all building on Algorand. State proofs, you just said it, is coming in July. How close is C3 protocol? How close is this London bridge?
Yeah, so on C3 we're finishing a testnet version so that people can start trying it out. That should be out in a month or so. And we'll, depending on how that goes, hopefully to release a product to mainnet sometime this year, at the end of this year.
And you talked about it a little bit earlier. So this is a derivative spot market, like cross-chain settlement protocol, right?
Yeah, so like C3, again, it's like what I always tell people building on Web3. It's like, at the end of the day, users won't care what blockchain or database you're using. They only care, right now there's a lot of tribalism where, you know, I use this protocol because this is my team or my religion or whatever it is. And
or
it's
your,
like,
your bag.
Exactly, right? Or your bag, more so than anything else, probably. And I don't think the future is like that. I think users are just coming to your app because it has, you know, 100% uptime. It's working well, flawlessly. It has a good user experience. They don't, if you're solving their problems, that's all they care about, right? So I do think there's gonna be a phase in which this tribalism is gonna go away, and real use cases are gonna come in, and that's where, like, that's how we're building C3, where we see how, you know, there's all this counterparty risk around by having your assets custodied in Binance or FTX or any of these exchanges, and the reason people are using not like the DEXs are not really conquering the market share from centralized exchanges, I think in big part is because how like you're always locked to an ecosystem, and as users they always want to trade. So C3 is trying to tackle that pain point by building a scalable, high throughput exchange where you can trade spot. You'll have access to capital markets to short and go leverage long, while also being able to cross margin with perpetuals and other derivatives to make the most use of your capital. And the cool thing about it is that you'll be able to use any wallet. It doesn't matter if you're using MetaMask in Ethereum, Phantom Wallet in Solana, whatever it is, you'll be able to use that wallet to lock collateral in C3 and start trading with no fees, no gas fees paying out, and using technologies like state proofs to be able to communicate across all those different chains, and leveraging Algorand for all the clearing and settlement of those trades.
And I think that's an interesting point you made earlier. At the end of the day, like a blockchain it's a puzzle piece in your tech stack. And
exactly.
If you're trying to build real world applications for real world consumers, not just the people that are in blockchain right now, like this is great, but there's more opportunity out there. And at the end of the day, the tech matters. Uptime matters, scalability matters, decentralization matters. And we want to have a world where these applications can build consumer grade products with the right technology for their applications and not have to worry about this tribalism or can I even interact with other ecosystems without adding additional risk. we think that we can get to this more like composable ecosystem where it's not just one silo that's living on a completely different island from a different one.
So for London Bridge, which didn't fall down, by the way, it just went digital. For London Bridge, we've added an extra feature, which is, it might turn out to be temporary, but it's something called secure enclaves. So we're using a secure enclave for the bridge itself. And that means that we can implement the Lite client there until it becomes cheap enough to do the full verification on Ethereum, or until we have the snark to do it very cheaply on Ethereum. So it's not really a middleman because it's a hardware secure environment that we can't interfere with, and the operator can't have access to or have access to the key. So we have all of that security, but we can also really reduce price on the Ethereum side because gas fees are quite painful.
Right. Yeah. So that's actually a good point. Yeah. So when you're using state proofs, they're very lightweight. They're compacting everything, right? That's, if I'm understanding correctly. So these gas fees are going to be much less, but there's still going to be gas fees nonetheless.
Yeah, so the idea is, like, in order to verify the state of a blockchain, I kind of talked about it earlier, but there's a lot of computation that has to happen to like run a full node. There's a lot of things moving in and out. There's a lot of signatures you got to check. With state proofs, you basically have this summary, and then you can just, without going too deep into like the tech behind it, you can fairly cheaply verify it. But we want to make it as cheap as possible so that there's a good user experience for the bridges that are built on top of state proofs.
Right.
So the snark proofs minimize that computational cost to verify each state proof, and then you can fairly cheaply ask it questions about, you know, the verified Algorand state.
But you could still use like the raw state proofs in more scalable blockchains, right? Where you really don't have to optimize that much on gas fees, given their like different characteristics, right? So it's optimizing for the Ethereum use case, but you don't really need to optimize that much for other chains.
Right. And you can use any wallet. You mentioned you can go from MetaMask to all this on your protocol, but it doesn't matter which wallet you're using and all that, right?
Well, you'll need to build the Lite client on different blockchains, right? So probably the highest priority would be Ethereum, but the idea is that now that state proofs are out, anyone could build a Lite client in the blockchain of choice, where the smart contract is being fed the state proof to verify transactions on Algorand. So you have that, like, that's a roadmap basically.
Yep. So there's going to be like a network of Lite clients that all, verify this Algorand state, and then if you want to come back into Algorand, you build a Lite client from the other blockchain in some Algorand smart contract as well.
Got it. Yep. And you had mentioned in your presentation that there are other things than bridges. You know, like there's other possibilities. There's other things, oracles you mentioned. I'd be curious to hear other ideas that you guys have about how state proofs can be useful.
Yep. So there's another product that we've built that we call Silent Data, it's a privacy preserving oracle. So we can get data from Web 2 data sources, which might be private, people's accounts, maybe your Instagram account, your bank account, something to do with your company, and we can process that data privately and prove points about that data that we want to and verify them in the blockchain without sharing the data with the blockchain. So that's a way of kind of bringing trust that doesn't exist outside the blockchain into the blockchain itself. And what state proofs do is they go the other way, right? They take trust from the blockchain and they extend it out so that someone outside the blockchain can verify and still have the cryptographic guarantees. And then I was talking to Noah about this last night, and we realized you could probably join the two things together. So if you're checking that someone really is the owner of an Instagram account before you do something with them or before you buy something from them, then you can do that in the Algorand blockchain, and then you might want to take that token somewhere else. And on the other blockchain, you still want to be able to verify that information or that fact is correct, even though it originated not even in Algorand itself, but from outside. And with something like state proofs, we could extend that. So you could have those cryptographic guarantees even on the other blockchain. And you think about NFTs and where's the NFT come from? What's been its provenance? Who created it? When you move things around, you're potentially losing a lot of information through bridges. Right. But if you can extend the cryptographic audit trail and take it through a bridge and bring those cryptographic guarantees through so that you'll only buy something or you'll only trade if all of these things about it are true, then you really can have solutions that go across blockchains.
Right, and like there's some industries where interoperability, like we're not the only industry that faces this interoperability challenge. I used to work in healthcare tech, and there's always this big problem of trying to get these different electronic health records to communicate with each other, whether they're on the same network or a different one. And like, if we can solve this interoperability challenge within the blockchain ecosystem, that can extend outwards and help other industries that face similar challenges. So maybe there's some application on one blockchain that has some kind of healthcare data, and you can add a privacy layer on it to encode that healthcare data and selectively reveal it to people outside of the blockchain. You can then export that state to people that either aren't on the blockchain or to other blockchains. We'll see what use cases come out of this, but it's not just moving assets. You can also move information.
Yeah, I think one cool feature coming up, maybe you can talk about it, Noah. So Silvio, he was the inventor of like verifiable random functions, and there's this a new upgrade coming to Algorand that's going to enable to use the blockchain itself to create a random oracle, meaning that an oracle that can output randomness depending on your use case for games, lotteries, whatever it is.
Yeah, we're building that as well, by the way.
Well, that's an example, right? So that's a way in which you can leverage a network to generate a randomness and then export that feature of randomness to other ecosystems through the same network, right? Through state proofs, and then having other applications, regardless of where they live, get input of randomness for their use case from Algorand.
Cool. We have a few minutes. I feel like I might be missing questions that you are wondering. If there's anybody out there that has a question, does anybody have any questions? No? No questions? All right. Well, then we'll keep going. So I was just thinking about this when, Algorand doesn't fork. It's, essentially impossible for Algorand to fork. So if you're communicating to Ethereum or whatever, Ethereum could potentially fork. What is the, how does that work? How does this work that it knows it's going to the right place?
Yeah, so Adi is building a bridge himself, so we can probably talk to like the practical solutions for this. But because Algorand has instant finality, you know that when a transaction settles on the blockchain, it's done. There's no question of, is it sort of there? Is it almost finished? Like, when is it going to happen? On Ethereum and other blockchains, not to silo anyone out, you have other types of problems where you have to wait for a number of blocks to have the confidence level that what you've seen on the blockchain is not going to change. So if we're importing state from some other blockchain that's not, instantly final, then you might have to wait some number of rounds like other applications currently do. But the nice thing about state proofs is once you see them, that's it. They're there. Yeah. It's not going to change.
The attack vectors are even worse. So from Ethereum, you could potentially fork the chain and then in a fork lock up your tokens. So you haven't actually locked up your tokens in the real blockchain. So your bridge, there's no real way of knowing that you're talking to the right Ethereum. There's ways of guessing and having higher probability, right? Hash rate and so on, but there's no guarantees. So you have to rely on the bridge to know that it's talking to the right network, the right instance of the Ethereum network.
Right.
And not another one that's just been forked or popped up that might even have the same data in it.
Right.
So there's a class of problem that he's addressing, and the way that's normally addressed is purely through a network where each of the players on the network are all saying, yes, we've got this from the right version of Ethereum.
Yeah, and it impacts latency as well, where if you're bringing information from, let's say, Ethereum to another place, you have to wait for it to be final, or like highly likely to be final, and that takes like a minute or several minutes, depending on how conservative you want to be. But when you have like instant finality in Algorand, it's a very good use case to export stuff with low latency, right? Like if you want to export a price oracle that's pushing information to the blockchain of Algorand, and it becomes, that lower latency becomes an edge. Or if you're using this random oracle as an example, then having the capacity to know that in 4 seconds you have finality and then you can feed the data to another chain is a benefit in this case, or a competitive advantage.
But by the way, I want to relate to your earlier question about the smart contract, because it's a controversial one.
Okay.
Right? I remember when, I've been in the space since 2015, right? And there's a lot of things that happened. When these new layer ones came out, a lot of the claims that were made by many of the layer ones is actually Solidity isn't very good, right? It's very limited, it's not very developer friendly, and actually here are all these much more flexible languages or much more optimized languages and primitives that we get with a blockchain that makes things easier. So actually Solidity was seen as a handicap, right? What's happened in practice is because obviously people have got confidence in the Solidity contracts that have been out there, then people just want to replicate them relatively easily. But that might be a short-term reaction, right? Because these other smart contract languages, some of them have some real advantages over Solidity, right? In the case of Algorand, I mean, it's very optimized in order to give Algorand the qualities that it has, right? In order to be able to be so performant and not to compromise on decentralization, and all these optimizations are built into the language. So yeah, there's a higher cost to actually learn and know to deal with it, but there's some benefits there as well, which may well be worth waiting for, right?
And I mean, this is true. So I mean, certainly you guys have been building on Algorand for a long time. You're the senior product manager. You've been building on Algorand before it even, over 3 years ago, we found out today. And you too. And I remember we have a few minutes, so I'm just going to humor this. I remember at Decipher, you were talking, and you made a case for, okay, yeah, maybe it's a multi-chain future, but also, there could be a chain of chain type of situation. Is that something that you're still, I mean, you kind of made the case for that a little bit just now, but are you still thinking that?
I mean, the thing I said at Decipher was, I spent 3 years, as many of you probably did at university, doing a degree. And one of the only things I remember from a computer science degree was keep it simple, right? And I think we try and do that in all the applications that we build. It's very easy when you're a techie and you fall in love with the tech and you get passionate about it to have solutions that become more and more complex. And really, you need to pull back and make things simple. And we started off with single blockchains here, Bitcoin and Ethereum and so on. And we've created a more and more and more complex ecosystem, right? The fact that we have these multiple blockchains and we need to move across them is in itself a huge complexity. As a user, you don't want that, right? It's all friction, right? And it all introduces risk. So this is where we are now, but that's not necessarily where we want to end up, right? We want to end up in the simplest, most efficient solutions that we can have in our industry, right?
Yeah, I think I do believe in a multi-chain future. I think it's more so going to be related to the different technologies. I think EVM has a massive network effect, tooling, and there's always going to be a spot for that, right? And then there's going to be alternatives to that, and then people will. Rust has many toolings, like a lot of people know or prefer to develop on Rust as an example. So I think it's gonna gravitate more towards that, on how, depending on what the skills of your engineers are, they'll make you choose, hey, let's build on this database which is compatible with Rust, or let's build on this database that has Solidity, and based on that, I think decisions are gonna be made more so than anything else, and most assets are just gonna be completely interoperable, and I'm talking about 5-10 years down the line, not nothing.
I also think if you look at most innovations in industry and so on, that the technology tends to do this when there's all these innovators and everybody's coming up with alternatives, and then it tends to do that afterwards, right? As you get some more solid solutions and people converge around the sort of long-lasting solutions.
There would be one for each technology, right? Instead of having 10 or 20 EVM chains, you'll probably have 1 or 2. Similarly on the other side, so probably 4 or 5, a place for 4 or 5 networks, and that's it.
That's what you think in the future.
That's my opinion. Yeah.
So I mean, so the idea is that currently a lot of these different chains have different strengths, and people are hopping around for whatever their needs are. And your idea is, okay, they do this, but then eventually it starts to kind of come together.
And I would say the ones that stick to the core fundamentals, the ones that get the fundamentals right, the security, the cryptography, the real optimizations, the performance, and it's not the marketing going ahead of the tech, right? It's the tech going ahead of the marketing. That's where you're getting things right on the ground in the first place. That's, I think, where you've got more chance of getting it right in the long term. Yeah. If you're playing catch up on the tech, or you've got to reverse engineer now some good solid technology, that's much, much harder.
Right? All right, so we have a minute left. Maybe some final thoughts. Oh, you do have a question. Yeah. Do we have the microphone's coming, so it'll be on the stream.
Thanks. So exactly on this point, when you look at the types of formal research that universities that you work with, are there any themes that you're waiting to be completed or that you're pursuing now in order to stay ahead with the tech?
Did you get that?
Yeah. I mean, we're more at the application level, if I'm honest. So, let's say core protocol innovations, that's probably more.
I mean, on our side, next month we have this big release coming out where we're moving from 1,000 TPS to 6,000 TPS. That's a 6x increase in block size, which you don't really see that often. I mean, I'm kind of shilling us right now, but we really see like these different pieces coming together on the interoperability side, the scalability side, and the composability side to really set the framework for a really good piece of technology that will work for real world applications. We're not looking for just some fancy marketing name blockchain. Like, we want to have the scalability to support the next 10 million insert number of users that come to blockchains for real consumer grade applications, because I think that's what's going to drive the next bull market. So we want to be ready for that.
All right. Well, thank you, Noah. Thank you, Michel. And thank you, Adi.
Thank you, guys.
Thanks.